Welcome you all to this MOOCs online video course Theory of Yarn Structure. So far we have completed 6 modules. Today we are going to start module 7. This module talks about yarn shrinkage due to washing. Almost all of us experience this problem. When you wash a cotton cloth, it shrinks in dimension. Generally, we have a tendency to reduce the effect of shrinkage by chemical processing, so called sintering technique, we do that. However, the actual reason of this shrinkage of fabric remains unknown. In order to understand the shrinkage behavior of fabric, say woven fabric or knitted fabric, it is necessary for us to understand the behavior of yarn shrinkage. Why does a yarn shrink? Which parameters of yarn are responsible for yarn shrinkage? Is it yarn fineness, or is it yarn twist, or it is some other factor which is dominant in deciding yarn shrinkage due to washing? In this module, we will try to understand this behavior and we will try to see the influence of yarn parameters on yarn shrinkage due to washing. We consider the helical model of fibers in yarn. It is well known concept, often used in yarn modeling. We have discussed it in detail in one of the modules in this course. Helical model of fibers in yarn. We recapitulate this model. A general fiber is situated at a radius r in the yarn. It makes an angle beta from the yarn axis. If we cut the yarn along its axis and if we unravel, then we obtain this triangle. The base of the triangle is 2 pi r and the height of the triangle is 1 by z, where z denotes yarn twist and beta is this angle. So, if we apply trigonometry, we can find out tangent of beta is 2 pi r times z. Now, of course, there will be a fiber which is situated at diameter d as well. In that case, for that fiber we will write tangent of beta d is pi times d times z. In theory of yarn, this quantity has a name which is known as twist intensity. Generally we denote the symbol kappa for this, which is equal to pi times d times z. So, this is a very well known expression, as we know from helical model of fibers in yarn, and we consider helical model of fibers in yarn in this module too. Now, what is yarn shrinkage? Let us first define this. A cotton yarn contracts its length due to washing. This phenomenon is called as yarn shrinkage. How we quantify this effect? The effect of shrinkage, let us consider zeta is the original length of yarn. If we wash this yarn into hot soap solution, then its length will shrink. Suppose this is the length of yarn after washing and of course drying. So, what is the change of length? Zeta minus zeta prime is the change of length divided by original length. This is how we quantify shrinkage. Phi is yarn shrinkage. So, yarn shrinkage is defined by the change in length due to washing divided by original length. We can write this further as this. Okay. So, this is how we define yarn shrinkage. Now, we consider a helical fiber inside the yarn before shrinkage and before washing and after washing. So, how it will look like? So, what you see is two cylinders, one is having length bigger, however, its radius is small r. Second cylinder, what you see is that shortened in length, but looking bigger in diameter, its radius is r prime. So, r is the initial radius and r prime is the final radius after washing and drying, that is shrunk yarn. And L, now if we cut along the axis of these two cylinders and unravel it, then we will find out two triangles. In the one triangle, this is the fiber length, original length of fiber, small l. What will be the base? Base will be 2 pi r times zeta into z. Why z into zeta? Because that is basically number of coils, initial number of coils. So, that is why 2 pi r z into zeta, and this length will be zeta. After washing and drying, the same fiber will have a different length. Let us consider that length is L prime, and of course radius will change. So, this base will be now 2 times pi times r prime z into zeta, and this length is however z prime. We consider number of coils z times zeta does not change because of washing and drying. So, if we apply now Pythagorean theorem to the initial fiber length, L square will be equal to zeta square plus 2 pi r z zeta square, right. Similarly, if we apply Pythagorean theorem to the triangle after shrinking, then we will obtain L prime square plus 2 times pi r prime z square. This equation, next equation second one can be written in this form. In this form. So, two pi r z zeta square r squared by this. Okay. So, what we can see is that we can further write as prime square by L square into L squared plus 2 pi r z square into square prime by r square. Right. Now, this L square we will substitute from this equation. So, what we will get is L prime square by L square zeta square plus 2 pi r z zeta square. This is equal to zeta square plus 2 pi r z square zeta square r y square by r square. Now, in all these quantities this is common. So, it can be removed. So, what we get is 1 plus 2 pi r z square is equal to zeta prime square zeta square plus 2 pi r z square by r square, right. So, further we can write this expression, this plus 2 pi r z square into this by this is equal to plus 2 pi r z squared by r square, right. Now, this equation we can further write as so, what we do in the earlier expression, now this expression is somehow related to sinkage. So, we will keep it in the left hand side, rest all in the right hand side. If we do so, then we obtained is equal to minus this. All right. How we define shrinkage? Change in length by original length is equal to this. So, this by this is equal to one minus this, isn't it? We now introduce two quantities. One is relative extension of fiber length. We symbolize it by epsilon subscript L. How we define it? Change in length divided by original length. So, L prime by L minus 1. So, L prime by L is equal to 1 plus epsilon subscript L. We also introduce another quantity here, that is relative extension of radius epsilon r, change in radius by original radius. So, we can write plus this. Now, these two expressions we substitute, these three expressions we substitute here. So, this becomes 1 minus phi square. So, finally, we obtain is equal to L prime by L is 1 plus epsilon L square plus 2 pi r z square common L prime by L minus 1 plus epsilon r square. Now, this 2 pi r z can also be written as pi d z into 2 r by d, right. So, what we obtain is 1 minus phi squared plus pi d z square 2 r by d square 1 minus epsilon r squared 1 plus epsilon r square. If we take the square root and put phi at one side, so we will obtain phi is equal to 1 minus 1 plus epsilon r square plus pi d z square into 2 r pi d squared 1 plus d squared minus square. Look at this expression. This is the expression for yarn shrinkage due to washing. Right. Now, what this equation tells to us? It tells us a very interesting story. These parameters epsilon L, twist intensity kappa, epsilon r, this diameter d, they are constant for a given yarn. So, for a given yarn, epsilon L, kappa, capital D, epsilon r are constant. So, for that yarn, shrinkage is a function of radius. That means, this equation tells us there will be shrinkage of yarn different at different radii. So, yarn shrinkage is different at different radii. This is not possible. How a yarn can show different values of shrinkage at different radii? This is not possible. That means, there is something interesting. So, we introduce one assumption here. The assumption is that there exists a neutral fiber at a radius r is equal to r star. That fiber represents the whole yarn in terms of shrinkage. So, the assumption is something like this: there exists a neutral fiber at radius r is equal to r star whose values say 2r by d is equal to 2r star by d, epsilon r is equal to epsilon r star, EL, EL star. These are the values. They correspond which corresponds to a natural behavior of individual fibers in the yarn during washing and drying. So, we imagine a fiber which is a neutral fiber which is situated at this particular radius whose values are 2r by d is equal to 2r star by d, E epsilon r is equal to epsilon r star, epsilon L is equal to epsilon L star, which corresponds to a natural behavior of individual fibers in the yarn during washing and drying, then we are able to write is equal to 1 minus E L star squared plus pi d z kappa square 2 r star by d square 1 plus star squared minus 1 plus epsilon naught star square. So, then this factor, this quantity becomes a constant, r star becomes a constant, d is a constant, this is constant, this is constant. So, in that case yarn shrinkage depends on yarn twist intensity. Pi d z. So, what we learn is yarn shrinkage depends on yarn twist intensity only. It is not only yarn twist, it is not only yarn fineness, it is not yarn twist, it is not yarn fineness, it is yarn twist intensity that dictates yarn shrinkage due to washing. Now, we would like to talk about these quantities epsilon L star, epsilon r star and 2 r star by d. About these quantities we would like to tell you. First, we start with parameter epsilon L star. What is this parameter? This parameter characterizes relative extension of fiber due to washing and drying. So, generally speaking, in different literature you will see this value is reported as 1.1% to 1.2%. In the book of physical properties of fibers by Morton and Hurd, you will see that a very similar values are reported for this quantity. Then comes another parameter epsilon r star. What is epsilon r star? It characterizes relative extension of radius. So, this is generally reported as 9.5% to 28% in literature, 9.5% to 28% generally reported in literature. Third parameter is 2 r star by d. What is the value of this quantity? This is the relative position of the neutral fiber inside the yarn, right. Based on helical model constant value of packing density at each radii, we can estimate this position by dividing the area into two halves. That means, this the radius is r star and this is the yarn whose radius is d. That means what? That means pi r star square is equal to half of pi d square by 4. Okay. So, what will be the value of this quantity? This pi and this pi cancel out. So, root 2, so 1 by root 2. So, this becomes 1 by root 2. So, 2 r star by capital D is equal to 1 by root 2. That means, this will be roughly equal to 0.7. So, based on helical model constant packing density, if we assume that at the where this radial where this neutral fiber is existing, it makes the yarn cross sectional area into two equal portions. So, 2 r star by d is equal to 0.7. Now, of course, this quantity might be different for different technologically spun yarns. They may be for ring yarn, rotor yarn, air jet yarn, friction yarn, probably this value might be different, right. So, this was about the discussion with 3 parameters. So, these parameters remains constant. This parameter, however, is a function of number of cycles of washing and drying. So, at the beginning this value will be less, as you go on washing and drying this value will increase, probably after certain number of washing and drying this value will not practically change. Now, we would like to go for experimental measurement of shrinkage. So, experimental measurements of yarn shrinkage. In this particular study, cotton carded ring yarns were taken. So, how the yarn length was measured? What was done is 10 hangs per 10 meter yarn length were prepared. the length of the hank was measured by using Instron tensile tester after applying a pretension. After applying a pretension, right. Then this yarn underwent one cycle of washing and drying, then this step was repeated after one cycle of drying, washing and drying. This step was repeated after 1, 3 and 5 cycles of washing and drying. So, this gives you initial length. These three measurements gave you length of yarn after first cycle, length of yarn after third cycle, length of yarn after fifth cycle. So, from these differences we obtained shrinkage values at different cycles, first, 3 and 5th. How did we wash this? Washing was carried out 10 minutes in water solution of soap 3 gram per liter and soda 2 gram per liter at 90 degree Celsius temperature. This was followed by rinsing using distilled water. So, this is how we carried out washing and how we carried out drying. Drying initially was carried out on air for 6 hours. Then four hours at 60 degrees Celsius. After that, conditioning at 20 degrees Celsius and 60% RH for 24 hours. So, this is how the experiment was carried out and we measured the shrinkage and we obtained the results. I will show you now the results. These are the experimental results of shrinkage after one cycle of washing and drying. We used many yarns cotton carded yarns, all were cotton carded yarns, but of different counts. 16 take a star. So, wherever you will see star, that correspond to 16 ticks. Wherever you will see plus 40 ticks, plus 40 ticks, rhombus 100 ticks, 20 ticks, 50 ticks, 30 ticks, 70 ticks. So, different fineness of yarns we prepared, and we obtained the value of pi times d times z. So, how we measured diameter? So, yarn diameter was also measured. Twist measured. From there we obtain pi dz, yarn twist intensity. So, this yarn twist intensity we plot along the x axis, and these are the results correspond to first cycle of washing and drying shrinkage. And this line is coming from theory. What is the expression of this line? 1 minus root over 0.9869 minus 0.1729 into pi dz square. Now, let me tell you one thing here. As we have seen, this expression 1 plus this minus pi dz square into 2 r star by d square 1 plus epsilon L star minus this, right. Now, 1 minus, see how we are writing this equation, this plus 2 r star by d 1 plus squared minus into pi times d times z. Then we consider 1 plus epsilon L star as equal to A, and 2 r star by d into 1 plus epsilon L star minus 1 plus epsilon r star, this we consider as B. Then we will be able to write yarn shrinkage 1 minus root over A plus B into pi dz. So, this line was obtained by using statistical regression technique, and the equation what we used for regression is phi is equal to 1 minus root over A plus B into pi dz square. By using statistical regression technique, we obtained the values of A and B. These values are written here. So, for first cycle we obtain 1 minus 0.9869 minus 1729 into pi dz squared. So, for cycle 1, what is the value of A? The value of A is 9869. What is the value of B? The value of B is 0 this, right, for cycle 1. Now, if we see here phi is equal to 1 minus root over A plus B into pi dz square. A, what is A? A is equal to 1 plus this. So, we will be able to obtain this value. And what is B? B is 2 r star by d into 1 plus square minus 1 plus square. 2 r star by d was considered to be 0.7. So, this is 0.7. The moment we know this value, we will be able to find out this as well, right. So, this was the result after first cycle of washing and drying. Then we carried out for third cycle. So, this is the result for third cycle of washing and drying. What we see as compared to the previous one, it is little increasing. So, for this what we found, similarly this thick line comes from theory. So, what is the value of shrinkage after third cycle? 1 minus root over 0.9937 minus 0.2888 pi dz square. So, this line follows this equation. This we obtain from statistical regression technique. So, what is the value of A? For third cycle, the value of A 0.9937 and the value of B 0.2888. Similarly, we measured yarn shrinkage after 5 cycles of washing and drying, and after 5 cycles of washing and drying we obtained this result. Similarly, this comes from theory. After 5 cycles we obtained 1 minus root over 0.9865 minus 3018 pi dz square. So, the value of A is this, the value of B is this after 5 cycle. So, 5 cycle, the value of 0.9865 and minus 0.3018 is the value of this after this. So, now if we use A from this table, we will obtain the value of epsilon star. This value was obtained as this. Similarly, if we substitute A is here, then we will obtain the value of epsilon star for third cycle, it was this. Similarly, if we substitute A is equal to this in this equation, so you will find out the value of epsilon L star, this value will be 007. You know B already for first cycle, third cycle, fifth cycle. You know epsilon L for first cycle, third cycle, fifth cycle. You know 2 r star by d is equal to 0.7, we consider it. By using this equation, you will be able to find out this value epsilon r star, relative extension of radius. This value was for the first cycle 0.157, for the third cycle 0.258, and for the 5th cycle interestingly it was 0.266. What we see that this difference is much higher than this difference. So, probably number of cycles of washing and drying epsilon r is probably after a few cycles there is a plateau that comes in. Now, why does it happen? Because yarn structure initially because of washing it swells and it shrinks. So, it opens up. Once it opens up, then further swelling is probably not possible. That is why this plateau comes. So, after 5 cycles of washing we did not find much significant difference in results. So, what we see is that our equation of this form is able to explain the experimental results quite satisfactorily. So, probably the way it was imagined helical model and then simple extension of helical model, the shrinkage of yarn was explained satisfactorily. Now, we would like to solve one numerical problem on this module. The numerical problem is like this: predict the shrinkage of a cotton carded ring yarn of 29.5 tex count and 719.43 meter inverse twist. So, this yarn has a count 29.5 tex, it has a twist 719.43 meter inverse. Considering that the cotton fiber shows 0.7% decrease in length minus 0.007 and yarn exhibits 16% increase in its diameter due to washing. So, diameter increase and radius increase will be proportional 1/6. So, you have to predict the shrinkage. Okay. So, shrinkage you have to find out yarn diameter. Diameter is not given, twist given, count given, diameter is not given. So, if we go back to module 4, we can find out diameter. How you know? We will use this expression only thing is that we need to know about packing density, because for cotton fiber rho can be taken as 1520 kg per meter cube, capital T is given 29.5 ticks, what is not given is mu. So, we have to use module 4 some formulas to find out mu. Which formulas? If you remember this equation, z square T half. This equation we derived in module 4. The value of Q for cotton carded ring yarn 9.61 into 10 to the power minus 8 Q. right, and Z was 719.43 square into T to the power half, T 29.5 to the power half. This value you will see will come as 0.2702. If you solve this by using a suitable numerical technique or by a table prepared before, please refer to module 4, then you will find out mu is equal to 0.46 for this yarn. If you now know mu is equal to 0.46, then you substitute here 4 into T, T is 29.5, 3.14 into 0.46 into 1520. This value you will get as 0.2318. So, you now know D. The moment you know D 2318 millimeter, what will be the value of kappa? Pi times D times Z. So, 3.14 into 0.2318 into Z 719.43 meter inverse. So, this you will get 0.5236. This will be the value of kappa. So, now you know all values. You know this value 007, you know this value, you know kappa, you will consider this we consider, then shrinkage is equal to 1 minus 1 plus epsilon L star square plus kappa square 2 R star by D square into 1 plus epsilon L squared minus epsilon R square. You substitute all values what are available to you, 1 minus 0.007 square plus 0.5236 square into 0.7 square, 1 minus 0.007 square minus 1 plus 0.16 square. All values are given. If you do, you will get this answer 0.0761. So, there will be approximately 7.6% shrinkage of this yarn. This ends the solution of this problem, and also this ends this module 7. Thank you very much. Thank you for your attention.